Hi guys, today we are graphing sine and cosine with negative sinusoids. This is section 2.4a in our textbook. And so far we've talked about only sine and cosine where the a value is positive, right? So we know that sine looks, I'm sorry if my screen goes a little weird today. We know that our sine graph looks like this for one period. And if a is negative, in algebra 2 we talked about a being negative as a reflection over the x-axis. So if we do the same thing and we talk about, a reflection over the x-axis, that means instead of going up, we're going to be going down. And this is what our sine and cosine graph looks like, right? Or our negative sine graph looks like. For cosine, we start at the top, and then we're going down and then back up for a period. But if I have a negative cosine, that means I'm going to start at the bottom. Bottom instead, sorry. And I'm going to go up, and it's just going to be flipped. Okay, apologies, my graphs are a little wonky today. So let's take what we know and just basically everything stays the same except for this final, like, where do I put my points? So our sinusoidal axis is still, sorry about that. Our sinusoidal axis is still y, oh goodness, not blue please. Okay, is y equals 3, right? That's right there. Our amplitude is always positive, so we know that we want the absolute value of a, which is positive 2. That allows us to start at our midline of 3 and a max and add 2 for a total of 5. And then we start at 3 and we go down 2 for 1. So our graph line is going to be right here at 3 and then 1 and then 5. Alright guys, there's going to be a few interruptions because I'm trying to do this at home with dogs in the background and a kid next to me. So I'll try to make this fast. What we're going to do is draw in our guidelines. You don't have to draw these guidelines in, but I find them really helpful. Okay. And then number of cycles in 360 is always your absolute value of b, which is also 2, right? So, but it's this 2. Okay. Phase shift is if there were a number that you were adding or subtracting to theta, but there is none. So it's 0 degrees. And our period is 360 degrees divided by b, which is 2. So that'll give me 180 degrees. We know that 180 degrees divided by 4 is 45. And that's my distance between critical points. So I'm going to count by 45s starting at 0. So there's no phase shift. And for sine graphs, we start in the midlines. Okay, so I'm going to count by 45s. Please excuse my rough iPad work here. I just can't get the hover cam to work right now. Okay, so those are my 3 points. Now, normally we go up from the midline. Well, today, since there's a negative right here, okay, in front of the 2, in front of the 2 sign, we're going to be going down. And so we're going to go down, come back to the midline, hit the top, and then come down. And then we know that we're counting by every 3, so here are my graphs, and I'm just going to do a dotted line to show, sorry, it's a little rough there, to show that we are extending our graph by 2 cycles, okay? Critical points, I think at this point you can fill in yourself. Please make sure that you have degrees on the x values. Okay, I'm going to skip this since my video is just not the best right now. I'm sorry, quality-wise. I might have to re-record this. So sinusoidal axis for the second one is -2, right? That's our c value. Our a value is -1, and our b value is 3. So our amplitude is always positive, so it's 1. If we go from -2 up 1, that's going to be -1. And if I go from -2 down 1, it'll be -3. Okay, this is gonna get a little bit too close. So I want -1, -2, and -3. So I'm gonna count by 2s and call this -1. Here will be -2, and this one will be -3. Just to give us a little bit of space. Okay, and I'm gonna be up here. Excuse me, I'm so sorry. So number of cycles in 360 is 3. There's no phase shift right now. And our period, sorry, I'm having like a coughing fit. So let's backtrack. Period is always 360 divided by B, which is in our case 3. So that's 120. We're gonna have 120 degrees divided by 4 is our distance between critical points, which is 30 degrees. And I can now count by 30s, right? So I'm gonna mark off 30 degrees, 60 degrees, 90 degrees, and 120 degrees. Okay. So now, what I'm gonna do is, we know that cosine usually begins at the maximum, but because we have reflected it over the x-axis, right, or a vertical reflection, we are gonna begin down at -3. I'm gonna come to the midline. I'm gonna go up to the max, and then back to the midline, and then all the way down to the minimum. And if we extend this graph, it will continue in the same pattern all the way down. Okay. Hopefully you can see that and write the critical points for that. I'm just gonna move forward now and just assume that you guys can write the correct critical points. So example 3, I just wanted to talk about how right now nothing changes except that this amplitude, let's see, is 6, so this will be 7 because we're starting at 1, adding 6, and starting at 1, subtracting 6 will be -5. This one now has a phase shift, and our last lesson was on phase shifts where we had to factor out the B value. If you notice here that B is already factored out, it's 3 parentheses theta plus 90. So our phase shift is just -90 degrees. Okay, 360, number of cycles in 360 is 3. And so now we know that we have a phase shift of 90. Our distance between critical points is going to be exactly the same as before because our period is the same since our B value is 3 again. So let me just write that all in. 3, that equals to 120. Oh, so sorry. So we have 120 degrees divided by 4, which is 30. And then we are going to count by 30s, but since we're shifting 90 degrees to the left, every single one of these, but I can't count by 3s because that's not enough. So I have to count by 2s. Okay, so this will be -90. I'll do it above, -60 degrees. -30 degrees, and then over here will be 30 degrees. Don't forget 0 also. So let's see, I've got 7 all the way up here at the top. No, I'm sorry, there goes my dog again. And then I've got a midline at 1. And then I have a minimum value at 5, -5, which is down here. And so since it's a sine graph, we are starting at our midline, which is right here in the middle. Maybe I'll use a different color just so that we can be more clear now. Right here in the midline, right? This one, just to be clear, notice, oh, that takes away everything. This positive tells us that we're going up for our next graph. So I just wanted to show you that, like, it's not always up, down, and it's not always up, right? So you have to make sure that you check now if your A value is positive or negative. Let's see if I can then continue this. And then I come back here, okay? So the practice problems on the back are a little bit trickier because you do have to factor out sometimes and other times you don't. They also could be tricky because our phase shift and our distance between critical points could be counting by different things. So in this case, you'll notice that to get to negative 90, I can count by 30s. But if you can't, you have to figure out what the GCF is so that you know what you're counting by. Okay. Hopefully this takes care of all of your questions for today's homework. Give it a try and let me know if you have other questions.